All right, okay. Are you all done for B? Where do you get the answer? Anyone? Where do you get the answer for B?
Madam,
Yes.
I got 16.
Okay. You got 16. Naveen, is it?
Yes.
Okay. All right. Okay. The rest of you, anybody got differently? Anyone got differently? Different answer? Okay, so the answer is actually 16. The answer is 16, correct? Okay, let's look at the answer. Okay, so 1 minus, basically, first of all, you got to change your 1 minus I into your rectangular form. And again, if you identify your 1 minus I, in which quadrant this 1 minus I lies, it is actually, it's the same like previous, all right, where it lies in your quadrant, in quadrant 4, right? So this is actually is in quadrant 4. Okay, so which means that angle has to be angle in quadrant 4. Okay, theta or argument is the argument in quadrant 4. Okay, so straight away compute for the r. So r is x squared plus y squared. So basically it will be your 1 squared plus minus 1 squared. So you have your square root of 2. This is your r. And then theta is tangent inverse y over x. So basically it's minus 1 over 1, or you have your minus 1. Okay, so you have your, okay, minus 1. Sorry about this. So basically it's minus 1. So if you use your calculator will give you minus 45 degrees, because we have done this many times before. Tangent inverse of minus 1, calculator will give you 45 minus 45 degrees. But again, remember we said that when we write a polar form, our theta or our argument has to be in terms of positive angle. So in this case, then it has to be 315 degrees. So therefore, okay, 1 minus I in terms of polar form of a complex number can be written as square root of 2 and then cosine 315 degrees plus I sine 315 degrees. So this is our polar form of a complex number, okay, for 1 minus I. So then now what we want is to take care of this power I, which sorry, to take care of this power complex number here with this power 8. That means we are going to raise the whole thing to power 8. Okay, so the whole thing to power 8. So then only using our de Moivre's theorem, so it will be r we raise to that power 8, and then for cosine, our argument we just multiply, so 8 times 315. Okay, plus I sine 8 times 315. All right. Okay, if you use your calculator, okay, you get this is 16. And then for argument, you will get 2520 plus I sine 2520. Okay, but because question asks you for rectangular form, at this stage, you can straight away use your calculator. So if you use your calculator, you will see that what you have is actually is for cosine 2520, you will get 1. And for sine 2520 degrees, you will get 0. So then the answer is 16. So this is rectangular form. That means it's only the real part, no imaginary part for this for this answer, for this complex number. Okay. All right. Okay, any question?
Madam,
Yes.
I want to see the R value.
Okay, say again. R
I want to
value.
see the,
They are here.
yeah. Why it is minus 1 square, madam?
Oh, because of this is this one. For this complex number, 1 minus I. So we are comparing it with our x plus yi. Okay, rectangular form. So we compare our 1 minus I with x plus yi. So x plus yi is our standard form of complex number in rectangular. So when you compare this and this, so x equals to 1. So y equals to minus 1. Is it understood, Mia?
Okay, understood, madam.
Okay, all right. Okay, so which means that this is actually can also be written as 1 plus minus 1i, isn't it? So that's when you get your 1 minus I. So x is 1, y is minus 1. So your r has a formula of square root of x squared plus y squared. That's the formula for the r.
Okay, madam. Thank you.
Okay, welcome. All right. Okay, any other question? Okay, so basically that's all for our chapter 4. So your chapter 4 ends here. So we finish our complex number. So that means you can actually do your assignment questions, your last assignment question. So question for I think question 3, if I'm not mistaken, assignment 3 is the question is until here. You have to apply all this, this De Morgan's theorem. Whenever you see there's a power, definitely it's about De Morgan's theorem. Okay, all right. Maybe I can start with chapter 5 with the introduction. Okay, before we take a break, we can actually start with the introduction. Is everybody ready?
Yes,
Okay,
madam.
all right. So this is our last chapter. Okay, last chapter for the course, which is about this is actually it's about three-dimensional coordinate system, three-dimensional coordinate system and vector. So the main part of the topic is actually is on vector. Okay, let me just go through quickly on the objectives of the chapter, or basically by the end of the course, or by the end of this chapter, you'll be able to understand about what do we mean by three-dimensional coordinate system, okay, and you understand about what we mean by two space and three space, two-dimensional space and three-dimensional space, and vectors in those coordinate system, as well as by the end of the chapter also you will be able to understand the different concept between two vector product, namely dot and cross product, and be able to compute them. Okay, so our content for this chapter consists of about like 4. Okay, and the main part is actually is the last 3. Okay, so basically this 5.0 and 5.1 basically just an introduction only. Okay, introduction of the three-dimensional coordinate system. Okay, but the main theme of the chapter is actually is on this, which is about the vectors. All right, vectors and their properties. Okay, vector and their properties. So dot product and cross product are also basically the arithmetic operation on vectors as well. Okay. Okay, so I'm not going to read all this. So you have actually some explanation in the module as well, talking about the importance of vector and how the application. Okay, what are the application that mostly use actually vectors concept. Okay, but basically just to show you that remember I mentioned last time about the mistake in complex number in the module, okay, where the diagram, okay, when they plot the complex number, remember I mentioned that when we plot complex number there shouldn't be an arrow. Okay, so that's a mistake because arrow is actually is meant for vectors. So vector basically you have an arrow because vector basically has what we call magnitude as well as direction. Okay, so magnitude and direction. So because of that's the direction, so it is actually represented by an arrow. So you know where your vector is actually heading towards to. Okay, so that is actually direction. Okay, all right. Okay, and okay, in terms of our three-dimensional coordinate system. Okay, if you remember, okay, the um, three-dimensional coordinate system, all right, we have actually also introduce you with the three-dimensional coordinate system. If you remember when we did matrix, okay, when we solve matrices, solving for uh, two equations with two unknowns, three equations with three unknowns. Okay, remember we said about having a intersection point. Okay, you have lines in space. Okay, if you have two equations, two unknowns, okay, you have like a two-dimensional system, two-dimensional coordinate system. So you have two lines in two-dimensional system. So when we solve two equation with two unknown, means that we are solving for intersection point in two-dimensional system. And if we are dealing with three equations with three unknowns, all right, so we are talking about three-dimensional system, three-dimensional coordinate system. So you also talk about intersection point of three line in three-dimensional space. Okay, so if you remember last time, I did show you how do we actually some sort like plotting points in three-dimensional system. So basically, plotting three-dimensional system. Okay, this is also another diagram. Okay, another diagram. So basically, when we talk about two-dimensional is straightforward, your XY coordinate. So when we talk about three-dimensional, we are talking about having a of course x, y, z. So if you are talking about three-dimensional, okay, this is the coordinate, okay, in three-dimensional, all right, coordinate system, okay, coordinate system. So when we draw, you will see that you have like three axes like this. Okay, you have three axes like that. Okay, now labeling in terms of x, y, z. This is just a standard labeling. The standard labeling for any three-dimensional, normally we will denote this line, this axis as the x-axis. All right, this one is the y-axis, and then the above this, like this one going up, this is z. Okay, sometimes when I normally I will draw like this. I will just draw like that. Okay, x, y, and z. And when we draw our coordinate or three-dimensional, okay, three-dimensional, basically when we draw, we just represent the axis. Okay, so this is the positive x-axis. This is the positive y-axis. This is the positive z-axis. So that means in the middle here is actually is the origin. So origin is actually is in the middle. So it is represented by 0, 0, 0. So that is the origin. Okay. So when you want to talk about the negative axis for the three-dimensional coordinate system, so basically the negative will be, all right, for the x, you just need to extend for the, all right, opposite direction. So that is the negative x. For negative y, you extend to the left here. So that is negative y. If it is negative z, you go down. That is negative axis for z. Okay. And if let's say we are teaching you this one face to face, if you are in face to face with us in class, so I would say normally I will say that actually z and y axis is like on I can write on the whiteboard because z and y is like two-dimensional, so it's like your previously x and y axis. So it's just that this is now y, this is z. So we can actually draw this y on the whiteboard, this one also going up. Okay, we can draw on the whiteboard, but x here is actually is the axis coming towards in front of you. Okay, this x-axis is just coming towards in front of you. So that's how you imagine. Okay, when it comes to three-dimensional axis. Okay, so this x is coming towards in front of you. So the negative x-axis is going behind the whiteboard. Okay, going behind the whiteboard. Okay. So when we talk about a point in three-dimensional space, okay, when we have like one point in three-dimensional space, basically that point is actually is hanging on the space. So you got to like imagine, okay? And how do you actually plot, okay? How do you actually plot if let's say okay, let's say plotting point, okay? Let's say again I have like this is my three-dimensional axis, so my x, y, and z, okay, y, x, y, and z. So if let's say I have a point, let's say I have a point, let's say point A is 3 1 minus 2, for example, and my point B is minus 2 minus 1 5, for example, okay, for example. So how do we actually plot? Okay, we will always start from the origin, from the middle. Okay, from the middle, from the origin. So let's say we want to plot for A, 3, 1, minus 2. So that means 3 is for the x, 1 is for the y coordinate, and then minus 2 is for the z coordinate. So then you will go like from the origin, go to the positive x axis for 3 units distance, assuming so this is 1, 2, 3. All right. And then 1 unit is positive for the y. So 1 unit to the right, positive, 1 unit. Okay, and then minus 2 is for z, so minus is going down, so going down 2 units, 1, 2. So this is just a rough sketch only. So this is just your point A. So that is your point A in space actually. The point is actually hanging in space, all right, in three-dimensional space. Okay, so that is how you actually plot roughly, okay, on a piece of paper, on our paper. Okay, of course there's no like graph paper, all right, so you just need to just do it roughly only, and logic, okay, and logically, logic, it has to be logic. So if let's say B you start from again from the middle, but this time B you have your x is -2, so that means you go behind the whiteboard, or we say you go opposite direction for 2 units, okay, for 2 units. And then y is -1, so that means you go to the left 1 unit, okay, you go to the left 1 unit, just rough sketch only, and then 5 positive, so you go up 5, so 1 2 3 4 5. So let's say this is the one, so that is your point B. Okay, so that is your point B, -2 -1 5. So basically that's how we actually roughly plot, okay, our point in three-dimensional space. And for the introduction, what is actually what we want to actually highlight is actually it's about plotting the point. How do you actually plot your point in three-dimensional space, as well as once you have a point, you can actually find what we call the distance. Okay, distance from 2 points. Okay, distance from 2 points, I'm sure that you still remember this by heart. If you're talking about two-dimensional space, two-dimensional space means your coordinate is only x, y, right? You have 2 points with x, y, x, y. So this is, I'm sure you still remember, this is how you compute for your distance, which is your square root of, all right, x2 minus x1, all right, plus y2 minus y1. That means this is where you have your point like P1 having this coordinate x1, y1. And then you have another point P2 having this coordinate x2, y2. So then when you want to find the distance between P1 and P2 for two-dimensional coordinate system, this is the formula. So when you have now three points, okay, all right, so you have now not 3 points, you have 3 coordinate in three-dimensional system, you have 3 coordinate x, y, z. So you just need to extend one more coordinate for the z. Okay, that's a typo also, this one about plus there. Okay, so this is actually is for three-dimensional, all right, coordinate system, finding distance from 2 points. So that means for this one is where you have your, like say P1 is your x1, y1, z1, and then your P2 is having this coordinate x2, y2, and z2. So you just need to extend it. The formula for distance is actually the same, except for you still have this one additional coordinate to compute for the z. Okay, so basically if you're talking about points in three-dimensional space, okay, for this just introduction for the three coordinate system, what is the most important is be able to understand in terms of the three axes, okay, the three axes, X, Y, and Z, and how do we actually roughly plot the points in three-dimensional space, and how to actually find the distance between these 2 points. Okay, so again using this formula. Okay, all right. Okay, so basically that is actually is what I would like to introduce on the three-dimensional coordinate system. So I think I can take a break for 5 minutes, and then we will continue with the main theme, which is on 5.2, which is about vector. Okay, all right. Okay, 5 minutes break. Okay. All right, is everybody there? Yes?
May I ask you something?
Yeah,
Madam,
sure.
kerja khusus stand for assignment, is it?
Kerja khusus means your carry marks for your assignment, test, those are kerja khusus.
Oh, all of
Because
it.
you only have kerja khusus means you only have kerja khusus and final exam. So kerja khusus consists of assignment as well as test.
Oh,
Like for
so
our subject is for test and assignment.
oh, that's mean the one that in the SMP is the from
Test
our
one,
test
test
and also
assignment one.
assignment one.
Yes,
I
assignment two.
see.
Assignment two, I haven't finished marking. I'm just starting to mark actually today.
All right. So it's mean
Okay.
40% is if it's that state there any number, it's total for 40% lah.
Assignment one and
Ah,
and
test.
test marks.
Alright.
I'm
Thank you,
not so
madam.
sure whether you can you see from your system your individual marks for like what is the assignment one, what is test mark,
It's only
or is it
state kerja khusus.
so it doesn't break up into the two parts.
Yeah, no.
Oh, so you do not know how much is your test.
Yeah, we
Oh,
just
okay.
we might know because unless the assignment result assignment punya marks dah keluar, baru kita orang
Oh,
can assume which one is our test mark, I guess.
oh, so you do not know lah which one is the test mark and which one is the assignment one Oh, so that
Yeah.
means they just sum up both
Yes.
Maybe I think like previously you can actually see, maybe
Oh.
because I do not know how it looks like from your as a student view. I do not know how the SMP looks like. I'm not so sure. But I thought that previously it can actually show you the breakdown. What is your assignment and what is your assignment one? What is your test?
Okay. Alright.
Maybe I can try ask around. Okay, I'm not sure whether you can actually view like that, or is it like straight away the sum of those 2 marks? I'm not so sure. But as of now, maybe like you said, is the sum of those 2 marks, right? Okay, assignment
Might
one and
be.
because I've already keyed in for both. So and if they mention they stated 40%, that means it's from assignment 1 10% and test 30%. Okay.
Alright, thank you, madam.
All right. Okay. Maybe I'll try to ask around. Because I'm not so sure how does it look like as a student's SMP. Because of course when on our part we have a button where we can actually check students' mark based on each of the coursework like assignment one, test, assignment two, etc. Okay. All right.
Thank you, madam.
Okay. Welcome. Okay, let's move on. Let's continue with vectors and their properties. Okay, hopefully this is also another refresher topic also for you, because I'm sure that you have done this before. All right, so perhaps this is just to refresh back your memory on vectors. And vectors, as we mentioned just now, it has magnitude and direction. Okay, so it has a magnitude and direction is represented by an arrow. So if you have a line when we draw a vector, basically, all right, we will say that, okay, this point is what we call the initial point, okay, or the tail of the arrow, okay, the tail of the arrow is what we call the initial point, and the tip of the arrow is what we call the terminal point. Okay, so it's understood if we say terminal point and initial point, so you know what it means. Okay, all right. And in terms of writing the, or in terms of if you read the book, if you refer to the books, all right, or any mathematical textbooks, vectors are written as like a boldface. Okay, you will see that they denote vectors using a boldface letter. Okay, so if they represent like A, B, C, or A, K, V, U, W with a boldface, or a letter with an arrow, so then this is about vectors. So you know that this is about vectors. All right. But if you see that there's a letter like italic in form, this is the scalar. Okay. Normally in mathematics, all right, if you have a scalar form, that's why you will see there's an italic form of the letter. So that represents scalar. Okay. But if you have like arrow or boldface, okay, then this boldface letter, then that represent vectors. So that's when you read the question, during your final exam, you can see that that is about vectors, okay? Because we can boldface the letter, all right, when we type the question. But when we write, okay, like here, if I want to write vectors, of course I'm not going to boldface. How can I boldface the letter? Okay, so then you will see that when I write, I would actually write using arrow, something like that. Okay, and sometimes you will see, you may encounter other people use this type of notation like a tilde. Okay, this is actually also vector representation in terms of writing, so because just want to distinguish, okay, to differentiate between scalar as well as vector. Okay, but most of the time we will just use arrow lah. Okay, we use arrow, so then this is about vectors. Okay, this is all about vector. Okay, and then in terms of terminology for vectors, okay, vector in space. If you talk about vector in space, all right. If let's say I'm referring to my three-dimensional space again. Okay, the three-dimensional space. Okay, you may have like vectors. This is one vector, maybe. This is vector. This is vector. Okay, all right. So maybe we can denote this as this is vector A, like that, or this is vector U, something like that. Okay, and all these vectors here is sometimes you will see that they call it a free vector. Free vector. Sometimes they call it a displacement vector. Okay, displacement vector. That means is everywhere. It can be anywhere in the three-dimensional space. Okay, it can be anywhere. So that is what we call sometimes free vector, or sometimes you may encounter the word like displacement vector. But if there's a vector which the initial point is at the origin, like this. Okay, let's say this vector W here. Okay, vector W where the initial point is tied to the origin. Okay, initial point is at the origin. This is what we call position vector. Okay, position vector. So when you come across this type of terminology, position vector, free vector, or displacement vector, okay, position vector. Position vector is a vector whereby the initial point is actually at 0, 0, 0 at the origin. However, the free vector, it can be anywhere. That means free vector or displacement vector, the initial point is not at the origin. Okay, so that's a terminology, yeah. All right, okay, and for vectors also, you remember you can equate them, or that's what we call equality of two vectors. Vectors are equal. Two vectors are said to be equal if they have the same length and same direction. Okay, same length and same direction. So assuming that you have this vector AB, or we can represent by U, let's say in this case, vector U, and another one vector V or vector CD. If they are same length and same direction, then we said these two vectors are equal. Okay, all right. And another terminology, all right, for vectors is what they call zero vector or null vector. Okay, zero vector or null vector means that its initial and terminal site, a terminal point coincide. Okay, initial and terminal point of a vector coincide. That means they are at the same location. So the length is actually is zero, and you cannot specify, you cannot determine its direction. So that is what we call zero vector. So this is just terminology. Okay, and then vectors also, previously you remember you can add, you can subtract. Okay, maybe I think last time maybe during your school days perhaps, you know, you are doing like adding and subtracting vectors from diagram. So you would actually do it from a diagram, either from like this triangle, all right, or like this parallelogram, okay, diagram, okay, where you add like this one. This is where this is vector U, this is the initial point, this is terminal point, and then there's a vector V here where the initial point actually is at the terminal point for U. This is its terminal point. Then U plus V means is this vector here. Okay, when you add, that means your sum of the vectors is here. This is what it means by adding two vectors. Okay, all right. And for subtraction also basically it's the same as addition. Okay, vectors subtraction is the same as addition. We can look at it as in terms of addition. This one. Okay, U minus V is the same as U plus negative V. Now, minus V basically, if this is your vector V, all right, this is your vector V, this going this direction, negative V is actually is the opposite direction. Okay, the opposite direction. So if this is our V, this is our minus V. And in terms of the length, it's the same. Okay, except for direction is the opposite. So then we represented by negative there. So that's when, okay, if you have like vector subtraction on the diagram, basically it is actually is the same as looking at it as a sum, but it's in an opposite direction. Okay, it's opposite direction. So you're going like opposite direction for the vector. Okay, but our course basically we are not going to draw. We are not going to like adding, subtracting from the diagram. We are going to add, subtract vectors from components. Okay, using their component. Okay, so this is just introduction part of a vector. So you have also another arithmetic operation that you can do. All right, beside adding and subtracting, you can also multiply. Okay, remember vector also, there's what we call scalar multiplication. Scalar means you have a number in front, okay, of that vector. For example, if you look at this is vector V here, okay, this much length here. Half times V means is half of the length, okay, half of this length. So that is half V. Or you can have 3/2 times V. So it will be this much, more than 1. If this is a 1, 3/2 is this length. Or you can have like multiply by a negative number, -1. So that means if you have a negative, means it's going opposite direction. Okay, so this is what it means by scalar multiplication. You can have like a number times by vector. Okay, so that is what we call scalar. Okay, but later on there will be another two types of multiplication, which is what we call just now dot product and cross product. So that one will come later. Okay, components of vector. This is what I mentioned just now. When we talk about vectors, okay, for this course, basically, when we want to add, subtract, even multiply by scalar, we are going to use what we call component vector. Okay, component vector is like coordinates, okay, in three-dimensional space, coordinate system. If in coordinate system, in three-dimensional coordinate system, we call it coordinate point. Okay, coordinate point. So vector, we call it components. Okay, Notation also, there's a slight notation. Okay, if it's coordinates, all right. If it's a coordinate for coordinate system in three-dimensional coordinate system, okay. Uh, if you're talking about, let's say, x, y, z like this we refer to coordinate point. Okay, it's a coordinate point. So we're using this type of bracket. Okay, so this is actually is a coordinate point representation. However, if you're talking about vector component, okay, then we are using this type of bracket. Okay, that type of bracket. So this is actually is what we call vector component. So vector component, similar concept to coordinate point. Okay, it's just that, all right, it's just that when it comes to coordinate point, that means you have like one point. Okay, like say this is your three-dimensional coordinate system. Okay, so your x, y, z. So point means just this one point there. So that is one point, your x, y, z, like that. But if you're talking about vector, okay, okay, for example, you have like this. Okay, then you have, then your component you can represent like that. Okay, however, don't get confused, when it comes to position vector. Okay, remember I said the word position vector. Position vector is the vector in which the initial is at the origin. Sometimes you may see also, all right, it is written like this. Okay, there's a point and then put like this. All right. Okay, because why? Because later on I will explain, because you have like, if you want to form a vector, you must have 2 points. Right? You have a 2 point, means the initial point and terminal point. So if you have 2 points, right, from your initial and terminal point, then only you can form a vector. You can form a vector, a direction vector. Okay, so that's why if it's a position vector, because the initial point is actually is 0, 0, 0. Okay, that's when, all right, the vector component will be just like some sort like similar to this point. Okay, this is the representation of its component, but it has also this point as its terminal point. So the representation, okay, inside is actually more or less the same number. This is actually same number, but except for just this is like this type of bracket, this is this type of bracket. Okay, when it comes to position vector. But if it's a free vector or other than vector not at the initial is not at the origin, then it will be different. Okay, it will be different. Okay, but just comes back to this vector component or components of vectors. Okay, this is what we call vector component, which is similar to a concept of coordinate. Okay, coordinate point in three-dimensional space. So this is actually is one way to write vector component. There is another way of writing a vector component. Okay, using what we call using a unit vector. Okay, using a unit vector in the direction of positive x-axis, positive y-axis, and positive z-axis. Okay, this one actually, the explanation is actually I have the explanation almost at the end, but maybe I can just highlight this also again. But we will come back to this also, okay, at the end for unit vector. But as of now, this is just to show you what we mean by a unit vector. Okay, because then this unit vector also can be another representation of vector component. We can use this, all right. This is also is a normal type of also vector representation using the ijk, if you remember. Okay, using the ijk. So basically the ijk, all right, the ijk form is actually is a unit vector. It's a unit vector in the direction of positive x-axis, positive y-axis, positive z-axis. Okay, somehow this diagram, okay, this diagram for three-dimensional, okay, it labels this as z, it's x and y, but it's actually, it doesn't matter. Okay, as long as if it is positive x-axis here, this is I. J is actually is a representation for a unit vector in the direction of positive y-axis. Vector K is a unit vector, all right, in a direction of positive z. Okay, so this is also, because it is a unit vector, all right, you can actually use IJK as another type of what we call a component representation for vector. So what is actually is a unit vector? Unit vector is actually is a vector of length 1 unit distance. That is what we call a unit vector. The word is a unit. Okay, so a unit vector. So come back to here. Okay, so another representation also is in the form of what we call the IJK. IJK. Using the IJK. IJK basically is a unit vector in the direction, okay, in the direction of what we call of positive, okay, positive axis of x, y, z just now. And a unit vector means, okay, it means it's a vector of 1 unit length. Okay, 1 unit length or 1 unit distance, 1 unit distance or 1 unit length. It has a length equals 1. This is what it means. Okay, that means this I, the length is actually 1 unit. 1 unit distance. So 1 unit distance from where? 1 unit distance from the origin. Okay, 1 unit distance from the origin, but it is in the direction of positive x-axis. J is 1 unit distance from the origin in the direction of y-axis. K is a, all right, it's a unit vector, all right, in which it is 1 unit distance from the origin, but in the direction of positive z-axis. So that's why sometimes previously, all right, if you remember, okay, if you remember, you will come across a vector, like for example, U vector has 2i minus j plus 3k. You have this type, right? Okay, so that means this is actually, it can be written as this type of representation for vector component. Or this also can be said as 2 minus 1k. That is another vector representation in terms of component, component vector. Okay, so either you say vector U has this component, okay, or this component is the same. This is how we represent component of a vector U. Okay, but representation must be correct. If you are using just a number like this, make sure the notation is this type of bracket. Okay, don't use this bracket. Don't use this bracket because this bracket represent a coordinate point. If it is a vector representation, it has to be in this form of a bracket. Or you can write in terms of ijk, okay, in terms of unit vector ijk. So this is what we call vector representation in terms of its component. Okay, and of course, if it is a two-dimensional vector, you will see only I and j. Okay, only 2 numbers. Okay, like when I write ijk, you understand that this is referring to the 3-dimensional. This is referring to the 3-dimensional vector. Okay, if it is only ij, all right, you may have, like for example, another example maybe v vector equals to 0, 2. So it's understood. If it is written like that, it means you are referring to 2-dimensional vector. Okay, that means there's no I, but it is just 2j. Okay, 2j can be written like that. So that is actually referring to 2-dimensional vector. Okay, so this is just what we call the vector component, component representation of a vector. All right, and okay. All right, okay, and then if let's say just now I mentioned the IJK. for the three-dimensional, okay, let's say I draw again the ijk. That means it is actually is a 1 unit distance from the origin. So assuming this is 1 unit distance, 1 unit distance, 1 unit distance. It's all 1 unit distance. So that means this is your I, this is J, and then this is K. Okay, that is K. All right. Okay, so if let's say we can say just now, if we let U equals to, let's say 1, 2, minus 3 just now, or just now we write as I, J, K. How do we actually plot this? Okay, if it is just this one vector here, okay, if you are given U equals to this, for example, so how do you plot? Okay, so how do you plot this? Basically, this one actually, this is your what we call your position vector. So the way you plot, it is the same like you plot like just now the three in a three coordinate system. Just now I show you plotting a point. Okay, it is similar. That means okay, referring to here or here, okay, which means that we will start from the origin, okay, from the origin, and then this says that you are going to, all right, remember I is actually is a 1 unit distance going to the positive, all right, direction of x-axis. J is actually direction is towards positive y. K is towards positive z. That's the direction. Okay, so if you have like this I, that means from the origin you go to the positive x 1 unit, but this is going to the, after that going to the positive j 2 units, and then going to the negative direction for your z 3 units. Okay, or you can just refer to here also. This is x, y, z. Okay, you are referring to that. So it actually is similar to what we plot just now earlier for a point in three-dimensional space. All right, so that means you have your 1 unit, assuming this is 1 unit to the positive x-axis, and then after that going to the right 2 units, okay, assuming that this is 2 units, and then going down 3 units, 1, 2, 3. So that means this is actually, I can write it as like this in terms of a point, can, but because why? Because this is actually it's a position vector. So my vector is actually is like that, okay, with an arrow. So that means this is actually is my vector u. So vector u is there. Okay, all right, so that's how we plot. Okay, if you have, for example, let's say vector w, let's say w is given as minus 2j, sorry, okay, can, minus 2j plus 3k. And let's say just given like this, minus 2j plus 3k. It means there's no x, right? No I. Or if I write in terms of this type of component, it will be 0, minus 2, 3. Okay, so which means starting from the origin, nothing for the x, right? Okay, nothing for the directions toward x-axis, but you start with the direction toward the negative of y-axis. So going to minus 2, so that means going to the left 2 units, and then going up 3 units, 1, 2, 3. So which means this point, you can also write in terms of coordinate like this. For position vector, it is still correct. You can write like that. Okay, then your vector is actually sorry guys about this. I need to share again. Um, okay. Okay, sorry about this. I accidentally pushed another button just now. All right, okay, so back to here. All right, so then you need to draw your vector, your line here. Okay, so this is the line. Okay, and then you draw your arrow. Okay, so that is your vector W. Okay, so if you want to write also, you can write in terms of component like this. Okay, so this is how we plot, okay, our position. This is actually position vector. If you are given straight away, let U be like this, okay, it is understood. This is already like, in a way, this is like your position vector. If we want to plot this, this is how we plot. Okay. All right. Okay. And there is another terminology for this type also. This representation here, the IJK, they call it actually standard basis. Standard basis or standard form. Okay, it's the same. So they call it standard basis of a vector in terms of the IJK. That's the terminology, because sometimes you may see that the question may ask you like, write the standard basis form of a vector. So if they want you to write in terms of the standard basis form, that means they want you to write in terms of the IJK instead of this type of component. So they want you to write this type of component. Okay, so this is just a terminology, standard basis. Okay, then vector also you can add, okay, of course just now we mentioned we can add, subtract, multiply by a scalar. Okay, so you have actually a list of theorem. In the book, it's actually there. You can actually go through here in the book. Okay, a list of theorem in terms of, U plus V equals to V plus U. Okay, remember theorem, last time I mentioned, this theorem means that left hand side equals to right hand side. It's always a true statement. Theorem is actually a true statement. Okay. Okay, that means if you have a vector, U plus V is the same as V plus U. You will get the same answer. Okay, you have that theorem. You also have this theorem. Okay, another theorem is for operations on vector component. Okay, how do we actually add, subtract, and multiply a scalar from a component? So here it's quite straightforward. Okay, here you are given, like, say, one vector V which has this component V1, V2, V3. Okay, another vector W with this component. All right, of course, if it is three component, it's understood they are vectors in three-dimensional space. If you are given in terms of two components, all right, if you are given in terms of, for example, V is given as V1, V2, then it's understood this is just vector in two-dimensional space. Okay, so you can tell whether that is a two-dimensional vector or three-dimensional space vector. You can tell by just looking at the component. Okay, so if let's say in this theorem you have these two vectors given, all right, in terms of their components. So when you want to add or even subtract, basically you just add or subtract using similar component accordingly. That means V1 and W1, V2 and W2, V3 and W3. You don't mix up, because then V1, V2, V3 is some sort like referring to X, Y, Z coordinate. So when you add two vectors, X coordinate and X coordinate, you add or subtract. Okay, Y coordinate and Y coordinate. Okay, you subtract or you add. Z and Z coordinate. So that's how we add or subtract vectors. So that is very straightforward. And when you have scalar multiplication also, you have a scalar K times V. That means that you just multiply that scalar to each of the component. Okay, so you have that theorem. Okay, so maybe let's look at example. Maybe we can just do one quick example to make sense of what we talk about in terms of adding, all right, and subtracting, as well as scalar multiplication. Okay, so let's do this. So let's see if, let's say you are given vector A as this 4, 0, 3, and you're given vector B as this component minus 2, 1, 5. Okay, then find, all right, let's do this. Vector A plus vector B. Okay, are you all ready? Okay, so vector A plus vector B, that means we want to add 4, 0, 3, add with minus 2, 1, 5. So earlier we said that when we add or subtract, so x and x coordinate, y and y coordinate, z and z coordinate respectively. So 4 plus minus 2, and then 0 plus 1, and then 3 plus 5. So that's the sum. Okay, let's do B. Okay, let's say A minus B, vector A minus vector B. Okay, that means you want to subtract 4, 0, 3 by minus 2, 1, 5. So again, you are going to subtract, all right, x and x, y and y, z and z. So 4 minus minus 2, 0 minus 1, and then 3 minus 5. Okay, all right, so that is vector A minus vector B. Okay, if you have any question, you just let me know. Okay, C 2A plus 5B. Okay, I hope everybody can follow this. So that means 2 times A is 4, 0, 3, plus 5 times B is minus 2, 1, 5. Okay, so you multiply 2 to each of the components. So 8, 0, 6. And then 5 you multiply by, all right, B component. So minus 10, 5, 25. Then only you add accordingly. Okay, 8 plus minus 10, 0 plus 5, and then 6 plus 25. Any question? Okay. All right. I hope everybody can follow this. Okay. Then the next one. Okay. Now we come to what we call vectors with initial point, not at the origin. So that means we are talking about free vector, vector in space, anywhere. It can be anywhere, depending on what is the given initial point as well as terminal point. Like just now, we mentioned about position vector. Okay, position vector earlier, I mentioned that assuming that this is our XYZ. Okay, assuming that you have like one initial point vector, where initial tied to the origin. Okay, so this is what we call just now a position vector. Okay, so let's say this is our vector U. Okay, so U has this component x1, y1, z1, for example. Okay, so if that this U has like this x1, y1, z1, Okay, that means this this terminal point is actually is the point x1, y1, z1. And initial is of course is the origin 0, 0, 0. That's the initial point. Okay. Now, from this theorem, it mentioned that, all right, if you have P1, P2 is a vector in 3 space with initial point P1 is x1, y1, z1, and terminal point P2 is at x2, y2, z2, then a vector P1, P2 equals to, okay, this is how you come up with component vector, all right, for P1, P2 vector in which initial point is not at the origin, which means for this theorem, what it is saying is that if you have, like for example, this is your x, y, z, okay, assuming that maybe for example at this is the point P1, and this P1 is at the point of x1, y1, z1 is a point, and you have another point here, assuming P2 is having this point x2, y2, z2, all right, and to find vector P1, P2, okay, vector P1, P2, if we write a vector like this, P1, P2 like this, which means P1 here is the initial point. P2 is actually is the terminal point, referring to the terminal point. So when you draw a vector, a straight line with an arrow, okay, all right, arrow will be like this, okay, because the arrow, all right, the tip of the arrow is the terminal point. So then only you have this P1, P2, and from the theorem, it says that in terms of component vector, what you need to do, it will be terminal minus initial for X, terminal minus initial for Y, terminal minus initial for Z. That's how you write in terms of vector component. Okay, vector component for P1, P2. Okay, so that's why just now, when it comes to position vector, all right, earlier I mentioned, if you have a position vector where this is terminal point x1, y1, z1, where this vector u can be written also in terms of its component also is the same x1, y1, z1. Why? Because of initial is at the origin 0, 0, 0. Okay, initial is at the origin 0, 0. So if let's say I denote this is my P1, the initial is P1, my terminal is P2, or this one is P2. Okay, the terminal is P2. All right, so my U vector here is the same as Okay, can you hear me now?
Yes, madam.
Okay, let me just start again. I think it's something about internet, because it's like it's loading. Okay, so I hope you can hear me now. Can eh? All right. Okay. All right. So come back to here. All right. Come back to here. Just now I'm explaining this part. Okay. This is how you find your vector component for vector in which initial point is not at the origin now, is somewhere, all right, at this point. This is the terminal point. So for vector p1 p2, the way you find its component, it has to be terminal point minus initial point for x, and then for y, all right, for y component is the y2 minus y1, for z component is z2 minus z1. Okay, so that's why for this position vector, okay, position vector, remember that for position vector, initial is at the origin. Okay, initial is at the origin, 0, 0, 0. Terminal point is at x1, y1, z1. So assuming that P1 is here, initial, P2 is at the terminal point here. All right. So if let's say vector u is the same as P1, P2 vector, all right, so then the component, it will be terminal minus initial, and then terminal for y1 minus initial, which is 0, and then for the z also z1 minus 0. That's why you have your x1, y1, z1. So that's why for position vector, you would see that you can say that this is either a point, okay, or you can say it's a vector. It's the same, okay, because of your initial is at the origin. So don't get confused. So the way we find it, the vector component is also similar to the theorem where said that if P1 is not at the origin. So basically they are actually the same procedure or same method when we find its component, component vector. All right. Okay, let's do some, maybe we can have time for maybe one or two more examples. Okay. So let's do this quickly. Okay, so find the vector represented by the directed line segment with initial point A has this coordinate 2, minus 3, 4, and terminal point B has coordinate of minus 2, 1, 1. Okay, what does it mean? It means that they just want you to find, in another way, it's like asking you to find what is, find vector AB. This is what it means. Okay, find vector AB. This is what it means. Okay, vector represented by the directed line segment. Directed line means you have a line with an arrow. Okay, initial point is at 2, minus 3, 4. Terminal point is at minus 2, 1, 1. Okay, so just use the theorem just now. All right, in terms of component, it will be for x coordinate, all right, terminal minus initial for x. For y coordinates, all right, terminal point, which is the B, minus initial at the A, okay, etc. So that means For X component, it will be terminal minus initial. For Y component, terminal is 1 minus initial is minus 3. Okay, for Z, terminal is 1 minus the initial is 4. So basically, you have your minus 4, 4 minus 3. Okay. All right, maybe another example. Okay, another example. Okay, given A is 3 minus 5, 6, and B is 4, 1, 3. Okay, so you have to find vector AB as well as vector BA. Alright, so again, every time you are given like this, A, B, that means A is the initial, B is the terminal. Okay, so this is initial, the initial point. This represent terminal point. Okay, similarly, if you ask for BA, B now, for B, for part B, that vector B is, the point B is the initial point. Okay, A is the terminal. Okay, so don't get confused, because then when it comes to component, you have to make sure that it's the terminal minus initial, okay, something like that. Okay, so let's do the first one first. For AB. Okay, what will be the answer for AB? Quickly, somebody. And everybody can shout me the answer for part A.
1,
Louder? Yeah.
1,
1.
6, -3.
Okay, 1, 6, -3. Okay, anybody got any different answer or anybody don't understand? Please let us know. What about BA?
-1, -6, and 3.
Yes. Actually, AB and BA, what's the difference? The difference is actually is the direction, isn't it? The arrow. It is actually is the same length. The only difference is actually is the direction. One is going, let's say this is A, this is point A, this is point B, for example. Okay, so AB means going this way. And then for BA means it's going this way now. So it's just, the difference is by -1. That means AB equals to negative BA. Alright, negative BA. Okay. So if you know AB, BA is just minus of each component. Alright. Okay. It's already 4 o'clock. I still have actually some more. Okay, but I think I can just stop here. We can actually continue this next week. We still have 2 more weeks to go. Okay, so inshallah we will be able to finish by week 15. Okay, so this is now week 13. So we have another 2 more weeks, which is week 14 and week 15. So week 15 is our last week for the lecture. And then your week 16 is your study week. Then week 17, you will start your final exam. Okay. All right. So I think I'll stop here. Anybody got any questions to ask before we end the session? Then I will continue on next Tuesday. All right. And in the meantime, as I mentioned earlier, for this Thursday tutorial, we will be discussing a complex number. Make sure you have also done, make sure you do the questions so that it will be faster to discuss. If you have done, we can actually discuss very fast. Okay. And as I mentioned, I don't expect there's so many problem with complex number. Okay, maybe the only difficulty is actually is the lengthy of the computation, perhaps maybe. All right, but you can actually sit down and do it patiently and passionately. All right, then you can actually get the answer. It's not that difficult as not as difficult as your application of trigonometry. Okay. All right, so I think I end the session now. I can stop here. So we will.
Madam,
Yes, okay.
I want to ask about the De Moivre theorem.
Okay.
Is this acceptable for the final answer in decimal
Yes, yes, acceptable. As I mentioned just now,
in
right?
rectangular form lah?
Sorry?
In the standard form or rectangular form?
Oh, you mean rectangular form or standard form? You're
Hmm.
using decimal. If you want to write, for example, 16 plus 0.43i, this is still in the standard form. That means this is your x, this is your y. So you have your x plus yi, still in the standard form. It's just that you are not using the exact value for your y. So it's still okay. Unless it
Okay.
mentioned x and y must be exact value. It mentioned x and y exact value, that means you cannot use decimal. But normally for complex number, they will not mention about like answer must be in exact value. Okay. Normally
Okay,
the word
madam.
exact value. Okay. Normally the word exact value you will see this in trigonometry. Okay. All right. Any
Okay, thank
more?
you,
Any
madam.
more? Okay. Welcome. Any more question? So I think you can start doing assignment 3, yeah? You can start doing assignment 3. And then again, just to remind you that the due date for assignment 3, all right, is actually next week, isn't it? Next week. Okay, next week, Friday. Okay, week 14. All right, week 14. So that week 15, we can have a time to discuss, all right, the answer. Okay, then week 16, you can do your study week. You can revise and review your course, okay, during the study week. All right. If there's no more question, then
Madam,
okay. All right.
can you share the this meeting to me later, madam?
Okay. I will try to share the link in the ULearn. I will do that. Okay.
Oh, okay. Okay,
Okay.
madam.
Maybe I will share. I think two link. This one, and as well as, if not this one, maybe I'll share the one that I had yesterday, because just now we had some hiccups, isn't it? And then I also did not actually record this session from the beginning. Only after 40 minutes only I realized I did not record it. So I think maybe I will share the one that I had earlier yesterday. Okay. But it is actually is the same. Okay, it's actually it's the same. It's the same content basically. Okay, it's just that perhaps you might hear me calling other names, not your friend's name in this group, because yesterday was with another group, BEEE. Okay, but basically in
Okay,
terms of
madam.
content wise, it's the same. Okay. So I will maybe by the end of the week I will share the link for the lecture, all right, recorded lecture, as well as the recorded tutorial. Okay, like the one that I shared already, right, for the previous week. Okay.
Okay, madam.
All right. Okay. Okay. Any more questions from everybody? Anybody? Anyone? All right. Okay.
Madam,
Yes.
do we have another task? Another test?
Oh no. Why? Do
No,
you
ah.
want another test?
No. I just, thank you, madam.
Okay. To be honest with you, all right. To be honest with you, previously, during, if we had like a face-to-face session with students, when we had like a time where result for tests was not that good, or the result was very poor, so what we had is actually we will give like a makeup test for everyone. Actually, that's what we did previously, because we want to actually help you. We are not like penalizing you. We do not want you to fail actually. Okay, we do not want you to fail. So what we had previously, when the result was very poor, then we will actually do what we call a makeup test for all students. So that means we will have like another round of tests for students to try to do well the second time, and we will take the highest mark, okay, between the two. But because this is now because of the pandemic, and then it's online, and you are not here, so it's like difficult. Okay, when like the result, honestly, for to be frank with you, test result is this time also is very poor. Okay, but we cannot do anything because of the pandemic, so it's very difficult to arrange, you know, and do certain things. Okay, because this is not like a normal situation, not like our normal classes. Okay, so in that case, then you just need to try your best for your assignment 3, because assignment 2 already over, right? You already submitted. So now you make sure you do well for your assignment 3, and make sure also you do well for your final exam, because this is now the only chance for you to push up your marks. If your marks is quite low, I'm sure that by now you know already out of your 40% how much you got. So if you think that your marks is very low, then you only have like assignment 3 and final exam to push, okay, for to get good marks. Okay, all right. And out of these 40 marks, okay, now remember our course for passing mark is actually is 40 marks, right? Okay, 40 marks is actually is the passing mark. So if you get like more than 40, all right, but okay, this is already like 40%. So if you are like 30 something, so that means of course the chances to pass is there, right? But if let's say out of the 40 marks you only get like very little mark, less, not even 10, okay, less than 10 mark, less than 5 marks, all right, you got like 1-2 marks, you know, out of 40 marks. So you have to be worried, because then you only have like assignment 3 and and final exam to push. But it is not impossible. Okay, you can actually do this. Make sure you, as I said, you must make sure you understand, understand the lesson, as well as you must work hard, do questions, all right, do the tutorial question, do whatever question in the book. Okay, and I think that you can actually push the marks, you know, for the course. Okay, so don't get so upset at the moment, you still have chances. Okay, but yeah, but back to your question, Anissa, no, you're not going to have another test. Okay, sorry to say.
All right, madam.
Okay, all right. Okay, so any other questions? So just make sure you attend the session. All right,
Madam,
attend the session and then understand. Yes.
sorry for interrupting. Just
Oh, it's okay. It's okay.
Madam was
No worries.
talking about the process, is it? So it's overall 40. So
Caution, say it.
yeah, the project process, right?
Caution.
Hello.
Okay, okay, all right. Because your
Yeah,
voice
yeah,
is not
madam.
clear.
For the project process, right? Yeah.
Okay.
In the assembly, they stated that the marker percent is 40.
Say again,
So,
Caution.
hello,
Your
madam.
voice is. Okay.
Now better.
Okay.
Yeah. So yeah, about the kerja khusus, is it? The total is 40. Is it included assignment 1 or assignment 2?
No, assignment two not yet, because I haven't marked. I'm going to mark this week. Assignment two.
So the 40% is including
Assignment
which one,
one.
madam?
Assignment
Okay.
one. Assignment one 10%.
Okay.
Test is 30%. Your test, your mid semester test is 30%.
Oh, okay.
So that make up 40% of the cost of the coursework.
Oh, okay, madam. Okay, thank you.
So,
Okay.
madam,
All right.
kerja kursus is include the assignment 1, assignment 2, and midterm
Assignment two
test.
not yet. Assignment two not
Ah,
yet. Because assignment two I have not yet marked. Okay. Assignment two
okay,
not
okay.
yet. All right. Only
Okay, madam.
assignment one and test. So test is actually 30%. Okay. Test is 30%. Okay, like I mentioned earlier, I'm going to, maybe afterwards, I'm going to share with you answers for tests. All right, I'm going to share with you. Maybe I will share in group WhatsApp. Okay, answer for tests, And then what I would like you all to do, since you all of you, I'm sure you have a copy of your test last time, right? You try mark your paper and give yourself a mark. Okay, give yourself yourself the marks for the test. See how much you get. Okay, I will share you the answer. But of course, there's no marking scheme. There's no marking scheme like 1 or 2 marks. But I think you can just guess. Okay, if this is the answer, all right, referring to the answer, and then that is your working. So if it is like 5 marks, what do you think you should deserve to get? You can actually roughly tell. Okay, so you do that so that you have roughly, you know roughly how well you did for your mid semester test. Okay, later I'll share you the answer. Okay, test answer. Okay,
Okay, madam.
all right. Okay, all right. Any more? Okay,
No.
if there's any more regarding the test or assignment or whatever marks, okay, you can still ask me during tutorial, okay, on Thursday. All right. Okay, so I think we can end our session today. All right. So thank you very much. I hope you have understood. All right, everything that we mentioned today. All right, we discussed. So I'll see you on. We meet again on Thursday.